Today we are going to take a look at section 2.4, which is solving equations with variables on both sides. So all of the equations that you have solved up to this point have had variables only on one side of the equation, either the left or the right. These equations today will have the variable on both the left and the right. In order for us to successfully solve, we have to get all of those variables together, either all onto the left or all onto the right side of the equation. So if we look at example A here, we can see that here's our equal sign, so here's our line through there. And we have D's on the left-hand side and on the right-hand side. This one on the right-hand side is a 1D. So in order for us to solve this, I need to get all of those D's together. So to do that, I am going to subtract 1D, so that's the opposite of positive 1D, on both sides. So subtract 1D there and subtract 1D here. When I do that, these D's here are going to cancel out. Negative 6 minus 1 is going to give me negative 7. So I have negative 7D. And that's going to be equal to positive 4. And then I just need to try to get D by itself. So to do that, I am going to divide by negative 7 over here and divide by negative 7 over here, which means that I end up canceling out these negative 7's on the left-hand side, so D is left by itself. Now, 4 over negative 7, we are going to leave that as a fraction, and since 4 over negative 7 does not reduce, it is just going to stay exactly that. So the fraction is negative, so negative 4/7. That is our answer to part A. Moving over here to part B, you will notice that something a little different is happening in that I have distribution on the left-hand side, but I still have variables on both the left and the right. So in order for me to start to figure out what I have going on with C, I am going to need to start by distributing the 2 to both terms on the left-hand side. So that tells me that I have 2C minus 12, and the right-hand side will stay the same because I did not do any distribution over there. So that side is still going to be 9C plus 2. So now I have C's on the left and C's on the right. So I need to get all of those collected together. So if I try to collect all of my C's to the left, I'm going to need to do the opposite of positive 9C, which is to subtract 9C. When I do that on the left-hand side, I'm going to line that up over here under its like term. So 2 minus 9 is going to give me negative 7, and then these here will cancel out. So I have negative 7C minus 12 equals 2. And now we are back to an equation like you would have seen in section 2.2. So now I just need to work to get C by itself. So we always move anything being held on to the variable by addition or subtraction first. So I'm going to move this 12. The opposite of minus 12 would be to add 12. So I'm going to add 12 here and add 12 over here. So the 12's on the left-hand side are going to cancel. 2 plus 12 is going to give me 14. So I can say that negative 7C is equal to 14 at this point. And then I need to divide both sides by negative 7. So 14 divided by negative 7 is going to tell us that C is equal to negative 2. So that is our answer for B. If we continue down here to example C, we can see that again, we have variables showing up on both sides. In this case, I have the variable M, but notice how on the right-hand side, the only term I have over here is 3M. So on the right-hand side, the only thing I have over there right now is something that has a variable. So I'm going to go ahead and collect all of the variables in that area. So this 1m that I have right here, I'm going to go ahead and move over. So I'm going to subtract 1m from both sides. So when I do that, I'm successfully getting all of my variables collected in the same spot. These here will cancel out, which means that I am able to say that negative 5, make sure you don't lose that sign on your 5, negative 5 is equal to 2m. And then I just have a one-step equation. So the only thing I have left to do is to try to get m by itself. So to do that, I'm going to divide by 2 on both sides. Now 5 is not divisible by 2, and negative 5 over 2 also does not reduce. So we are just going to leave it as that fraction. So we can say that negative 5 over 2 is equal to m. Or if you prefer that it's written the other way with your variable coming first, you can make that happen. So we can also write this as m equals negative 5 over 2. Those are the same. I don't care how you write it for your tests, but those do mean the same. So that is your answer for part C. So the last one that leaves for us on this screen is D. So you will notice on D that again, you have your variable, which in this case is K, showing up on both sides. So we need to work to get all of the K's together. So I'm going to start by subtracting 5K from both sides. So when we do that, subtract 5K here and subtract 5K over here with its like term. So these K's are going to cancel out. 7K minus 5K would give us positive 2K. So I can say that 2K minus 4 is equal to 16 at this point. And now again, we're back to something like you had in section 2.2. So now we just need to work to get K by itself. So we move anything connected by addition or subtraction first. So I'm going to remove that minus 4 by adding 4 to both sides. So I'm going to add 4 here and add 4 here. So these 4's will cancel out, meaning that I can say that 2K is equal to 20. 16 plus 4 would give you 20. And then my last step would be to get rid of this 2, so I'm going to do that by dividing. So I'm going to divide by 2 on both sides. When I do that, I will see these 2's here cancel out. And 20 divided by 2 is going to give us 10. So K is equal to 10. So we're going to move on and we're going to look at a story problem here. So on this story problem, it says a hairdresser is considering ordering a certain shampoo. Company A charges $4 per 8-ounce bottle plus a $10 handling fee per order. Company B charges $3 per 8-ounce bottle plus a $25 handling fee per order. How many bottles must the hairdresser buy to justify using Company B? So the important thing to notice here that's going on is that this hairdresser has two choices. One company charges her a little more per bottle but has a lower handling fee as compared to the other one. So our variable here, what we don't know, remember a variable is always an unknown, is we do not know how many bottles she's going to order. So we're going to let B be our number of bottles. That's what we're going to have for our variable. And then we also don't know what the cost is, but we are specifically wanting the cost to be the same because we've said how much will it cost her before it, or how many will she need to order before it will cost her the same. So the bottles is the main thing that we don't know. So if we look here for company A, she is going to be paying $4 per bottle. So since I don't know how many bottles, then that means that she's going to have 4 times the number of bottles. The number of bottles is an unknown, but she's going to need to add to this the $10 handling fee that they're going to charge her to ship her stuff. And this is going to tell us how much it costs. So we'll let C be our total cost. So I'm going to go ahead and label here for you your other variable of C, which would be cost. So then the other company, which is company B, is going to sell her the shampoo for a little cheaper. They're only going to charge her $3 per bottle. So for company B, we're going to have $3 per bottle. But for them, we're going to have to add onto it a $25 handling fee. So they're going to charge us $25 to ship us our box. And that's going to tell us, that's going to tell us our total cost. So what the problem is asking us is, when will these two be the same? Because she would need to order a certain number of bottles to justify using company B. Well, when they're the same, then she could justify using any company that she wants. So what we really want to know is, when will 4B plus 10 be equal to 3B plus 25? That's what we really want to know. So you see here that we have set up an equation that has a variable of B happening on both sides. So here's our wall through our equal sign, and we need to solve this. So I need to collect all of my B's together. So I'm going to subtract 3B from both sides. So I'm going to subtract it under its like term over here, which is 4B. So these B's are going to cancel out. 4B minus 3B is going to give us 1B, so just a B plus 10 is going to be equal to 25. And then my last step would be to get rid of this 10. So the opposite of adding 10 is subtracting 10. So I'm going to subtract 10 from both sides, which tells me that B is equal to 15. So she needs to order 15 bottles to justify using company B. At 15 bottles, she can use either company because they're going to charge her the same. In our next example, we are going to connect to an idea that you should have been exposed to in middle school, which is the idea of vertical angles. It says the measure of an angle is 5x minus 3 degrees. So this expression is representing the degree measure. Its vertical angle has a measure of 2x plus 12 degrees. When we talk about vertical angles, we are talking about having two lines or two line segments intersect with one another. And then the angles that are opposite each other are called vertical angles. So this angle and this angle would be vertical angles. When you have vertical angles, they are equal to one another. So in this case, we can say that 5x minus 3 is equal to 2x plus 12 and it's asking us to find the value of x. So in other words, it's asking us to solve this equation for x. So we have variables x's on both sides here. So we need to collect all of those x's together. So I am going to start here by subtracting 2x from both sides. So these over here will cancel out, And we can say that 5x minus 2x would give us 3x. So 3x minus 3 is equal to positive 12. Now we just need to work to isolate x, or to get x by itself. So we always remove anything being held on to the x by addition or subtraction first. So we're going to remove that minus 3 by doing its opposite, so plus 3. Have to do that on both sides. So we're going to add 3 on both sides of the equal sign. Oops. Which means that these 3's will cancel out, and we can say that 3x is equal to positive 15. And then our final step would be to get x by itself, and we would do that by dividing by 3. And when we divide both sides by 3, we can say that x is equal to 5. So moving on to our final idea in this section. So all of the equations that you have solved up to this point have had a single solution. So you have said x equals 4, or x equals negative 2, or x equals 1/2. But there are two other options that can happen for us. One option is that we can find out that our equation actually has no solution at all. Or our other option is that we can find out that our equation is an identity. If you already learned that in middle school, then you may have learned to write that the problem has infinitely many solutions, which is the same as identity. So we're going to take a look at these last two examples and see what that looks like. So in example A here, you will notice that I have an equation that has, again, variables on both sides. So I'm going to do the same thing that I've been doing, and I'm going to work to collect all of the variables together. So I'm going to get all of the n's together. So to get rid of this 5n from the right-hand side, I'm going to subtract 5n. And if I do that on the right, I also have to do that on the left. So I'm going to subtract 5n from both sides. These cancel out. But if you notice, also on the left side, we're going to see these cancel out. So when that happens, the only thing we have remaining on the left-hand side is 9. And the only thing we have remaining on the right-hand side is negative 1. So we have this statement that has no variables in it at all that says 9 is equal to negative 1. We know that 9 is not actually equal to negative 1, so that statement is not true. And since it's not true, that means there are not solutions to this equation. So this is an example of having no solution. So from now on, you're going to have to watch for the option of having no solution now that you are aware of it. So if we then move over to example B, we will be looking at a similar setup. Again, we're dealing with an equation that has variables on both sides, but a little different this time. If you look at the right-hand side, you will notice that we have like terms over here. So our like terms on the right-hand side are 7x and negative 2x. So to start this problem, I need to start by combining those. So the left-hand side will be untouched, so this will stay 9 plus 5x. But on the right-hand side, when I combine, 7 minus 2x will give me 5x. So I will have 5x plus 9 over here. So again, I'm dealing with an equation that has variables on both sides. I'm going to work to get all of those variables together. So to get rid of this 5x, I'm going to subtract 5x. And when I do that on the right, I also have to do that on the left. So I'm also going to subtract 5x here. So these x's are going to cancel each other out. So these will be gone, which was my intention. But again, I also am getting canceling on the left. So that gets me to the point here where I have just 9 on the left-hand side. And on the right-hand side, the only thing that I have is 9 as well. So in this case, I got 9 equals 9, which is in fact a true statement. So when this comes out to be true, then what you have found is an identity. With an identity, what that means is you can choose any number that you want to for x to substitute into this equation, and it is going to work when you substitute it in. So I could substitute in -5, I could substitute in 23, I could substitute in 1002. It would not matter. Any number I wanted to substitute in would make that true.